Standard 9.1, interpret position tables or graphs using the language of calculus. So in this particular problem, we have a canoe. It's being rowed on an east-west path. So basically our canoe is going back and forth east or west. So here's our canoe, and here is west, and here is east. T is time in minutes, and F of T is the number of meters the canoe is west of a lighthouse that's on its path. So this is minutes, and this is meters west of lighthouse. Now it's important that we include the word west so we know exactly where the canoe is located. One of the first things you want to do when you see a table, or a graph rather, is to label the axes and then think about what each piece of the graph means. So in this yellow portion, what's happening in our graph? Well, it looks like the canoe is starting at 0, which means at 0 minutes it's 0 meters west of the lighthouse. And then it's traveling more and more west because the meters west of the lighthouse is increasing. And so it's going west, so it's traveling west, and it's located west of the lighthouse. So instead of a canoe, I should really have a lighthouse here. So here's our lighthouse, and looks more like a rocket ship, but that's okay. So it's starting at the lighthouse, and it's going more and more west. Okay, so that's what's initially happening. Then if we look at the next piece here, what's the canoe doing? Well, the amount of meters west of the lighthouse is decreasing. So that means it's going back towards the lighthouse. When it hits the axis, it's actually at the lighthouse. So it's going back to the lighthouse now. And when it's going back to the lighthouse, that means it's traveling east. Now it's still on the west side of the lighthouse. It's just going in the eastward direction. So travel east, still located west. Okay, when it gets to the axis, it's at the lighthouse. Now our next chunk here in purple, it's still going in the same direction. It's going, the slope is still negative. It's the y values are negative down here as well. So it's negative 50 meters west of the lighthouse. Negative west is essentially east. So it's continuing to travel in the same direction, but now it's located on the east side of the lighthouse, and it's still traveling east. So traveling east, located east. Then in our blue portion, still traveling more and more east, and it's still located east. So there we are in blue. And so still traveling east and located east. And then if we look at this red portion here, it's headed back towards the lighthouse. The lighthouse is here on the axis. So if it's headed back towards the lighthouse, then what's happening is that it's traveling west. So it's going back towards the lighthouse. So it's traveling west, but it's still located on the east side. So located east. And then our final piece of the graph here in black. Now it's gotten to the lighthouse when it hits the axis, and it keeps on going past the lighthouse. So it's west of the lighthouse, and it's traveling west. So this last piece is here in black. So each part of the graph in color corresponds to where the canoe is. So now let's look at the questions that are being asked here. What does a negative slope represent in the context of the story? Well, negative slope is the green portion and the purple portion and the blue portion. And if you notice, all of these portions have a negative slope, and in all of these portions the canoe is traveling east because the graph is headed downwards. It's headed more and more away from the west side of the lighthouse, which means it's traveling east. Part B says find f of 58 minus f of 0. So f of means the y value. Let's find f of 58. f of 58, if we find 58 on our axis, it looks like we're counting by 2's here. So f of 58 really is the endpoint. f of 58 is right here. Looks like we're counting by 10's on the y-axis, so that's 120. f of 0 is the y value at 0, so this is 0, over 58 minus 0, so this becomes 120 over 58, and if we do that division, we get 2.1 approximately. So approximately 2.1. Now let's think about the units. The numerators here in yellow measure y values, and the y value, according to our y-axis, is the meters west of the lighthouse, and the denominator here measures x values, which according to our graph are minutes. So the numerator is meters and the denominator is minutes, so when we divide the two, we get meters per minute, and specifically meters west per minute. So what does this represent in the context of the story? So the rate the canoe is traveling, on average, and we need those words on average because that's not the rate for each part of the graph, but on average, the rate the canoe is traveling is 2.1 meters west per minute. The next question is, when is the canoe being rowed the fastest? When we're talking about fastest, we're talking about the speed or the velocity, and that means we have to find the slope. So we're looking for where the steepest slope is. How do we find slope? It's rise over run. So let's find the slope for each portion of our graph. So this first portion here looks like our rise is 50 and our run is 10. So our slope is 5. Okay. The green and the purple are part of the same line, so we can find that slope. It looks like the rise is 150. And the run is, this is a little hard to read, 16. So the slope is 150 divided by 16. So 9.3. And these are both, this is a negative slope actually. But that's okay. The negative doesn't mean it's going slow. It just means it's going in the other direction. The blue is obviously less steep than the previous slope, so I'm not even going to bother calculating that. I'll just move on to the next piece, but you could calculate that slope. You're just going to see it's less steep. This next red portion, our rise, it looks like it's going from negative 120 up to the axis, so the rise is negative 120, and the run, it looks like it's going from 30 to 40, so that's 10, so the slope is, positive 120 and positive 10, so the slope is 12 here. And then the last portion looks less steep than the red one, so I'm not even going to bother calculating that, but you could if you wanted to. So which one is the most steep? It's the one that has a slope of 12. And so the canoe is being rowed fastest in this red interval, so from 30 to 40. And that's because it has the steepest slope. The next question is, what is the furthest east that the canoe travels? Well, going, the positive side here is west, the negative is east. So what's the most negative value? It looks like it's a negative 120 meters. And so it looks like it travels 120 meters east at a maximum. The last piece is what's happening in the context of the story from t equals 11 to t equals 40. So t equals 11 is right here at this point, and t equals 40 is at this point. And so it looks like the canoe is traveling east for a while and then traveling west, but it's always located on the east side of the lighthouse. So the canoe is on the east side of the lighthouse the entire time. And again, it's traveling both away from and towards the lighthouse, but always on the east side. All right, so the next part of the standard is looking at graphs, or tables rather. So here we have a table. This is the height of water that's filling for a bath. T is measured in minutes since the starting, and height is measured in inches. True or false, the water was definitely running the entire time. Well, it looks like the height is continuing to increase, but someone could have turned off the water and then turned it back on. We don't know. We only know what's happening at different snapshots of the situation, not the whole continuous part of the situation. So we cannot determine because the water may have been turned off at some point. And then just turn back on. Find the slope of the line for part B. So 5 comma h of 5 is 4, and 20 comma h of 20 is 20. And so slope is y2 minus y1 over x2 minus x1, which is 16 over 15, which is approximately 1.1. And let's put a unit on this. So the numerator are y values, and that measures inches. And we're dividing by minutes, so it's inches per minute. So on average, the tub is filling at a rate of 1.1 inches per minute. Question C says, estimate how fast the tub was filling at 10 minutes. So how fast is really the speed, which is the slope. So how are we going to do it at 10 minutes? Because 10 minutes is just one snapshot, one part of our graph. We have a couple choices. We can do the interval from 5 to 10, or we can do the interval from 10 to 15, or we can do the interval from 5 to 15. So we have to include 10 somewhere in our interval. And you'll get different answers for any of these intervals, but all of them are correct. So if we do from 5 to 15, I'm just picking one. The slope are the y values, so 15 minus 4 over the difference in x values, so 15 minus 5, and that's 11 over 10, which is approximately 1.1 inches per minute. So at 10 minutes, it's approximately filling at 1.1 inches per minute. Now we'll get different answers if we do from 5 to 10 or 10 to 15, but any of those are acceptable. All right, so we kind of explained ourselves in already for question D. And then in question E, it says, when is the tub filling the slowest? How can you tell? So again, this is a rate, and to find your rate, we need to find the slope. So let's find the slope for each interval in our graph. So here, if we do the slope, it's y2 minus y1 over x2 minus x1, and this is about 0.8. If we do the slope here, it is 7 minus 4 over 10 minus 5, so that's 3 over 5, which is 0.6. The next interval from 10 to 15 is 15 minus 7 over 15 minus 10, so that's 8 over 5, which is 1.6. Our next interval from 15 to 20, find the slope, so do change in y over change in x, and that slope is 1. And then finally, our last interval, change in y is 22 minus 20 over change in x, which is 25 minus 20, and our slope ends up being 2 over 5, which is 0.4. So what's the slowest rate? It looks like 0.4 is the smallest slope value. So in which interval is a tub filling the slowest? It's from 20 to 25 minutes. And you can just look at the y values. I mean, it's jumping 4, and then it's jumping to 3, and the next jump is 8, and then 5, and then it's 2. It's only 2